after that, just slowly put in those numbers that they're giving us, the 350 and the 500. The 500, yes, the 350 and 500. We already have this. We determined this. This was given to us. We determined this, and we subtract. And we did the same thing for these two, 72.8 and 28. We determined this constant is fixed now. So we determined what happened with 250 and what happened with 650, and we estimated that this is the number in between. It's an estimate. Don't expect 100%. Okay. Other questions for me? Okay, so I'd like to go back to and finish up the answers here. And let me just refresh our memory on the ones that we already did. So x approaches -3 from either side. -3 from either side. The function values get closer and closer to this. That's why we wrote 5. -2 from either side. -2 from either side. The left-hand side goes to 4. The right-hand side goes to 2. So that's the answer is D and E. It does not exist. From either side, it does not go to a number. On this side, I read 4. On this side, I read 2. They are not the same. They're not the same. It's D and E. Limit f of x as x approaches 4 from either side. From either side. We're not talking about the function value. It approaches from either side. It approaches 2. Not the value that it takes or it doesn't take. We are not asked for the function value. We're asked what does it approach? Where is the tendency? The tendency is 2. That's why we wrote 2. -2 from the right. -2 from the right. -2 from the right. The function values approach, not equal to. We don't care if it equals 2 or not. The tendency is to get closer and closer to 2. Finally, we want to answer these. X approaches 2 from either side. Can anyone answer for us? X approaches 2 from either side. X approaches 2 from either side.
4.
Yes, thank you very much. X approaches -5 from either side.
0.
Excellent. X approaches 6 from either side.
0.
0. Excellent. And last one. -2 from the left. Thank you. Any questions on this problem? Anyone? Any questions on this problem? Okay. I wanted to open the book. And it should be somewhere here in the background. Here it is. And look at one more graph. And the graphs are on page, I'm looking in the book for my page number. Page 113. Okay. So we looked at this problem. We answered everything from 25 to 32. I wanted to look at this problem. So let's determine the limit as x approaches 1, number 55. The limit as x approaches 1 from either side.
1.
Say it again.
Never mind.
It's okay if you're wrong. Anyone?
Are we looking at question 55?
Yes, yes. So let me emphasize something very important here. So see, when x equals 1, we do not see that, but the function has a vertical asymptote. You may remember this. We're going to talk about it later. Vertical asymptote. And as you notice, the function on the left-hand side of the vertical asymptote goes to infinity, and on the other side goes to negative infinity. So the graph looks like this. We are asked to find the limit as x approaches 1 from f of x. In order to determine this limit, because it's from either side, we have to determine the limit as x approaches 1 from the left, and we have to determine the limit as x approaches 1 from the right. So let's determine the one from the left. As x approaches 1 from the left, yes, I cannot have sleeves. That's what happens. My sleeve is catching the paper. Okay, so follow my marker. As x approaches 1 from the left, what do I write?
Would it be positive infinity?
Exactly. Awesome. Now on the other side, as x approaches 1 from the right.
Would it be negative infinity?
Exactly. Only now I can conclude what happens here. What does it happen? What is the answer?
Would it be both infinity and negative infinity?
Let's go back. When x approaches negative 2 from either side, what did we say?
That it was B and U.
Correct. So as x approaches 1 from either side, look what happens here. Where is the function going? What is the tendon?
Either positive infinity or negative infinity.
But can I tell you that I have in my bank account positive infinity or negative infinity? What is it? What am I having? Where is my bank account approaching? Where is it going? Back to this one. As x approaches negative 2 from either side, where is the function going? And you cannot give me this or this or this or that. No. You have to say it's going where? Where is it going?
Separate directions. Not the same direction.
It's going nowhere. Right? I don't have an answer. If they're not the same, I cannot give an answer. The limit cannot have this or maybe that or potentially both or potentially no. The limit exists if it's a number only. So let's write this a note. It's very important. Note. The limit exists if it is a single number, not plus or minus infinity. This is a symbol. If I cannot give you the number, the limit does not exist. So here, I was able to give you the number. As x approaches 4 from either side, the number is 2. I'm not saying that the function value at 4 is 2. No, I'm not saying that. I'm saying that x approaches 4, the function is undefined. F of 4 undefined. I'm going to post this again because it's part of this lesson. Okay? So if you ask me how much is f of 4, I'm saying sorry, I don't have an f of 4. But if you ask me the limit operator, I will give you the number. It's 2. Because these are not the same. F of 4 is not the same with the limit at 4. This is one operator. This is a different operator. This is, where is the tendency? Well, the tendency is 2. As x approaches -2, there is no tendency. There is a tendency from the left, which is 4. There is a tendency from the right, which is 2. But from either side simultaneously, none. I can't give a number. So the same thing here. From either side, I cannot give an answer. They are different. You can say from the left is infinity. From the right is -infinity. However, this and this are still DNE because it's not a single number. It's a symbol. But I cannot write DNE for this. I must write infinity, but it's still DNE because it's not a single number. For this one, I cannot write DNE, but it is DNE because it's not a single number. But I have to write infinity and I have to write -infinity. But why are they DNE? Because they are not a single number. Unique number. Okay, I think we got this idea. Let's go back. Any questions? Please stop me. Any questions? So now I want to ask something else. I want to ask something like 59. So I'm going to copy the graph again. And notice one thing. This is kind of a line here. It's a line. And this is another line. So I'm going to continue with this graph on a different page. So here it is. So if we are careful, and look carefully, I should say here, we get x equals 1. We have y equals 1. And we also have y equals 2. These are so-called horizontal asymptotes. So these two are horizontal asymptotes. And here comes the function. And I think it also has -3. Yes, it also has x equals -3 as a vertical asymptote. So here's the graph. On this side is this piece. In the middle, it goes from -infinity, crossing at 2, going to infinity. It was crossing. Let me just keep this on. Yes, crossing at 2. And then crossing at 3. Okay, this is important to understand how to read from graphs. And then we'll go to the algebraic part. Okay, so limit as x approaches infinity from f of x. Limit as x approaches negative infinity from f of x. So follow my markers. We start with infinity. As x approaches infinity, the y values get closer and closer, closer and closer to what?
1.
Exactly. That's the reason why this is a horizontal asymptote. Now let's look at this. As x approaches negative infinity, the function values get closer and closer, closer and closer, closer and closer to what?
Two.
Yes, that's why, and I have to write y equals 1 horizontal asymptote, y equals 2 horizontal asymptote. So that's the tendency. As x gets closer and closer to infinity, the function values appear to get closer and closer to 1. As x approaches negative infinity, the function values get closer and closer, closer and closer to 2. That's why this is a horizontal asymptote, y equals 2, at negative infinity only, and this is a horizontal asymptote, y equals 1, at positive infinity only. But I cannot just, when I graph a line, I cannot just graph this piece or this piece. I have to graph a line. And I have to graph a line. That's why you see them everywhere. So when we get the chance to, in a later chapter, when we get the chance to graph this, this is a deceiving graph. I wouldn't say it's 100% correct. I would, because the asymptotes are missing. But we are discussing these, so that's why they're not, I'm assuming that that's why they're not presenting the asymptotes. But we will always present the asymptotes in writing, always, when we graph these. Okay, I think we got the idea unless you need more examples. I would like to graph a piecewise defined function again and identify the limit that we are asked for, and then we can move on. Can we choose, let's say, maybe 73? Is that okay? Do you have another preference? I know we graph.
Sounds good.
Okay, so I just wanted to show again how important, so 73 on page 114, how important these piecewise defined functions are. So negative x plus 4 for x less than 3, and x minus 3 for x greater than 3, and they want us the left of 3, the right of 3, and either side. So they're asking us to graph this and then find the limit as x approaches 3 from the left of g of x, sorry. And then the limit as x approaches 3 from the right of g of x. And finally, of course, the limit from either side. Limit of g of x, x approaches 3. So we have to graph this function. And if you remember, we start by finding the domain.